Hello all. My name is Tom Barron. I work at Red Hat and I serve as the PTL of the Manila project. We're here today to talk with you about using Manila to provide shared storage, RWX storage for container orchestrators. Gautam, would you?
Yep, and this is Gautam Ravi. I am a software engineer at Red Hat as well. I've been working with Manila for about 3 years, I guess, or more.
He's been working more, I think. He's the guy I go to when I can't figure something out, which means I talk to him all the time. Okay. That works. How many people here have deployed Manila or work with people who deploy Manila, if I can put it that way? Some of you I know. All right, so there are a fair number here who don't, and may be saying they know what. How many people work with container orchestrators, Kubernetes, Apache Mesos, et cetera? Him and him. And then some of you with neither. OK. So that helps us calibrate this a little bit. Manila is a project in OpenStack for shared file systems as a service. So instead of people having to go ask their IT labs to hand them a share for their project, they can interact with the REST interface and provide it for themselves. So historically, it developed as a fork of Sender. And if you're familiar with the Sender project, some people say, well, Manila is the Sender for shared file system services. There's some truth in that, and there's some important differences, as we'll point out. Usually, people get introduced to Manila in the context of OpenStack as a whole. So if you look at the bottom right-hand corner, there's storage up there. There's Swift for object storage, Sender for block storage, and Manila for file system storage. And certainly that's a great way to look at it. Manila is the way Manila came into being. And in classical OpenStack, if we look at that, there's Nova over there where compute instances run. And people provision Nova compute instances. And if they want block storage, they use Sender. And if they want file share storage, they use Manila. What's that have to do with us today? Well, we've evolved from an OpenStack conference, an OpenStack world as we knew it, to open infrastructure. And we think Manila is well positioned in an open infrastructure world. As you see in this picture used to be shown with virtual machines, Nova compute instances, and illustrate the fact that you can, in OpenStack, have self-service multitenancy. So you could have one department, say, one tenant called marketing, and another called R&D, and they would work basically as ships in the night to each other, able to provision infrastructure for themselves and consume that on Nova compute instances. And that's the way it worked. And they were unaware, and they get isolated storage from one another and so on. But as we've drawn this picture here, the point is that Manila serves up storage over a network rather than through a hypervisor. We are not tightly coupled to Nova. We can serve file shares to Nova. We can also serve them to bare metal machines. We can serve it to containers. And in this case, we're interested in talking about serving them to containers who are orchestrated by Kubernetes or Apache Mesos, Docker Swarm, et cetera. If the Manila service architecture, if you look at it, all we really, I ran into several people today when at this conference, been in OpenStack a long time. And they said, what are you doing with those VMs you run? in Nova. You've got this dependency on Nova. What are you doing with that when you're working with containers? And don't you have a hard dependency on Sender? And these sophisticated people, I mean, they're familiar with Manila as it's been presented through the years. And the answer was, no, we don't have those hard dependencies, but you think that. I realize why. Because Manila has been traditionally introduced in terms of a generic backend driver that uses Sender block storage to build its file shares on, and that uses Nova VMs as the things that export the file shares, and that uses Neutron, of course, to deliver for the networking. But if you look at the core of Manila, we have an API service and a scheduler service, and we have share services with backends. And we need a messaging bus, which typically RabbitMQ, and we need a database, MySQL, Postgres, whatever, CouchDB. That's all that's really needed to run Manila. And that's, if you interact with it with OpenStack multi-tenancy, you need Keystone, because you got to get Keystone tenant and so on. But that is pretty lightweight. So just to reiterate, we work over a network rather than through a hypervisor. We're loosely coupled with the other OpenStack components. That might have been a weakness in traditional Nova-centric OpenStack. You couldn't use an OpenStack API to do the equivalent of a Nova attach of a Sender volume. You had to do a mount from the instance. When we asked Nova people to put that in, they said, why don't you just do a mount from the instance? We're having enough trouble with doing this with Sender. And in any case, it's a strength in the open infra world because we're loosely coupled, not hung up on that. Manila is an abstraction layer over different backends. So it supports both proprietary and production quality open source backends. There's some reference backends that are open source that are not production quality, that are upstream. Right now, we work for Red Hat. We've put a lot of work into getting the Ceph backend and Ceph with NFS to be production quality open source. As Manila PTL, taking off my Red Hat for the moment, I welcome anybody else who wants to build a great open source backend production quality. I love competition and fostering that stuff. Ceph, of course, is great because you can use it for object storage and block storage as well as file storage. So your investment in a Ceph cluster can pay off in all those ways across it, and Manila can be a part of that. We have worked so that we can use that same Ceph cluster to present shares over NFS in addition to native CephFS. Native CephFS has great performance advantages. It requires a trust model that may not be suitable for all enterprises, et cetera. So being able to do it with NFS, as well as just the ubiquity of NFS clients out there, is a huge advantage. And again, we can present these file systems to all kinds of clients, VMs, bare metal containers, inside or outside of OpenStack. Gautam's going to talk to us about container orchestrators.
So like Tom was speaking about I mean, it's been 9 production quality releases of Manila so far. And so we've seen a steady growth of people that are, of deployments that have been there around the world, different kinds of deployments, private clouds, public clouds, hybrid clouds. And so, and the shared storage needs for these were, were generically looked at, and the API has been evolving for all of these releases that Manila has existed. And then over the last couple of years, we've started seeing a whole another computing paradigm. And there are many names and approaches for this, but in short, without boring you into the details, I'm going to just call this containerized workloads. Right. So, and for managing containerized workloads as the as the ship sails, you're actually ending up using one of these container orchestration engines, and some of these are represented here by their logos, and some of them are more popular than the others. So many applications running inside these containers are stateless, and that's great. And that's what the containerized workloads started out with. That was the vision of it, the 12-factor app vision of having stateless workloads. But we realized that there are all sorts of applications and all sorts of use cases, and we are now seeing more and more need to actually have state as a first-party object inside these container orchestration systems. And so that's where something like reaching out to the underlying cloud provider and asking for some place to store its state comes in, the whole need for that. So with that said, many of us also make the mistake of thinking that a container orchestrator is a cloud. And that is and that's fair, because there's a fair bit of thought that goes into managing infrastructure with these container orchestrations or container orchestration engines, because they bring about a whole another paradigm of how you can do declarative desired state management of workloads over imperative workload management and so on and so forth. But the truth of the matter is that container orchestration is built around the need for a cloud underneath it. And the cloud underneath it is providing the infrastructure in terms of whether it's going to provide it bare metal or some sort of virtualization for the cloud, for the container orchestration itself to consume as resources. And that's what the basic architecture has been and continues to evolve. And if there's something that the container orchestrator is giving you in terms of putting aside infrastructure for something else, then yes, it's fair game to say that the container orchestrator becomes your cloud. But for the container orchestrator itself, you're going to end up relying on a cloud provider. And forgive me for overly generalizing, your cloud provider can be bare metal, sure. But at the end of the day, whatever you do, you need some way to, to hand over the resources that are there as part of your infrastructure out to these container orchestrators, so then they can actually hand it over to the application workloads that are running inside them. So the first challenge, of course, is provisioning. And this is an ancient, antiquated challenge, which we know how to solve very well. This is something that the OpenStack community probably had, I don't know, so many years ago. And that is, how do you provision? And so you have all of these different ways of storing data persistently, and you have different cloud providers today. You have public clouds, you have private clouds, and on private clouds, maybe you're using OpenStack, and you have your block provisioning service, Cinder. You have your file share provisioning service, Manila. You have maybe you're running just Ceph clusters or some other kind of distributed storage, probably storage from a vendor, and all sorts of different combinations of where you store your data ultimately. And the challenges now are, how do you provision across all of these different kinds of data, data storage units? So that's where I think the first and the simplest way to do it was, let somebody else handle this. Let them go ahead and just carve out sets of storage primitives and let it be visible up to the container orchestrator, and the applications are just going to consume it transparently because it just exists. Well, that works, and that worked greatly, but of course we ran into problems of, okay, this is just not efficient, and this isn't straightforward. The administrator has to anticipate what the workload's going to require, how much storage, when is it going to require it, and it's not elastic anymore. It's not self-service anymore. We're back to the old days of wanting somebody else to run the infrastructure for us. So then came in the need for dynamic provisioning, and this was the beginning of the wild, wild west, in my view. So we had all of these different public clouds, private clouds, different ways of doing clouds, and all of these different storage vendors that were there. They just rushed to market with their unique ways of doing dynamic provisioning. And the container orchestrators started indulging by giving them some sort of ways to do this dynamic provisioning. Whether it was just dropping some messages on an API server somewhere, or creating an interface, if you're familiar with it in Kubernetes, called the dynamic provisioner, or the flex volume provider, and so on and so forth. So they gave them some ways, but each one was, again, unique to to each of these container orchestrators. But it was working. I mean, and at the end of the day, it was up to the deployer or the user to find the best match of what kind of software, what kind of provisioner to use for their particular environment. And there were some problems with this approach, of course, that, this was the times when we didn't know which was the container orchestrator of choice for what kind of workloads and stuff. And I mean, some of that problem exists today as well. And what container orchestrators started doing was, as they evolved the interface to do this dynamic provisioning, they started having to make changes in all of these different dynamic provisioners that were coming in from these public clouds, storage vendors, and so on and so forth. And they soon realized this is a big pitfall. I mean, 2012 OpenStack. So that's when they said, okay, we've got to decouple this. And we've got to make sure that these guys can live independently and evolve independently for a lot of other benefits, not just the fact that they can go make their own bug fixes and backport them how many ever number of releases, or make specific feature enhancements and so on, but also for the fact that, hey, we still don't claim that there's just one container orchestrator that's going to win this race eventually. So let's go ahead, collaborate, and come up with a smarter design of doing consumption for container orchestrations. And then there's this second challenge. When you start splitting stuff into microservices, and your application workloads cannot be characterized by even just the words that are there on this slide. There are different deployment styles that you want your application to work in. There's different architectures that you've evolved into your application. I mean, we could think of it from an OpenStack perspective or from a virtualization perspective as compute VMs that are running on different compute nodes. And these compute VMs need some sort of persistent storage. So you're trying to give your VM running on compute node 1 a volume. And then you would like to give the same state to another VM running on another compute node. This is gross oversimplification for a container world, but there is some flavor of this problem happening even in the container side. Because whatever primitives that the container orchestrator comes with to make your containers behave like a scalable application, they're going to have these limitations of sharing state whether it is between the same application or different applications that still want to do some amount of sharing state without having to resort to using something at the application layer that can take care of managed state across this application for themselves. So some of these primitives, you would have seen them around in popular COs, read-write ones, read-only many, read-write many, single node architectures for all of these, multi-node architectures for all of these. And the node here is an abstract concept that belongs to each of these container orchestrators themselves. So with these two challenges as a main motivation, let's switch on to talk about CSI. You probably heard about this term quite a lot over the last year at least. It's graduated and it was being incubated as a project under the Container Native Computing Foundation. And what it is it's simply a spec in an architecture, a recommendation for an architecture. And the spec determines how an interaction occurs between a container orchestrator and your storage system. So if you do implement an API conforming to the spec, then you know that all container orchestrators that conform to this CSI spec are going to send you the same kind of requests. And it also, the spec also, the CSI community also gives you an architecture to run a lightweight driver to be able to talk to your storage system. Then that's the reference architecture we're talking about. And this soon became quite a popular integration point for infrastructure providers, mainly the public clouds, and of course, when you're using public or private OpenStack clouds. And the emphasis over here is not just provisioning. Provisioning is just the first challenge, and I mean, of course, it took us a little while to get that right, because it's a whole. I mean, you have to consider all of the edge cases around the container workloads that are there. So that said, why do we need to think about a CSI for Manila? Well, one of the major important things that Cinder or Manila can bring to you, have been bringing to you, is the fact that they are able to abstract away multi-vendor and possibly multi-protocol too in both places. And what that means is your end application or workload that is there doesn't have to worry about thinking about, okay, so is this writing to a Ceph-backed distributed storage in vendor X-backed storage system or a public cloud-backed something else? That's the kind of flexibility that your workload itself has, and that was the sole motivation for these two projects to exist at the beginning. And of course, we, from the very beginning in OpenStack, thought about multi-tenancy to build on the things of building a huge, scalable, multi-tenant cloud. And the storage has got to also be behaving in the same way. So two tenants are never going to discover or run into each other's data and provide that kind of security between them. And we have been, for a long time, when we got past the provisioning challenges, looking at the day two operations. And this is where the projects today can speak of their maturity in terms of giving you the ability to move your data and manage your data through the life cycle of that data, rather than just giving you a way to just create a volume or create a shared file system, delete your volume, and so on. Apart from that, of course, you'll want to ask, why do I need the complexity of introducing Manila when I could use one of these other integrations that have been written over the past year? And that's fair. And honestly, what I would do there is ask yourself, are you using a single storage system or a single family of storage systems? I mean, many people just run Ceph for their entire workloads. Then do you really need Manila to just talk to your Ceph? Probably not, because there isn't too much of an advantage if you're just using a homogeneous system, or if you're using vendor X, or 10 different classes of storage that vendor X provides, but they have this smart and good driver that's already integrated into these container orchestrators. So why bother with Manila? Smart enough again, because you really don't need to worry about orchestrating, managing your shared file system service when you're just going to use one storage system at the end. Or your deployment's really simple and you just have one tenant. So do you really need your CO to be talking to a Manila or a Cinder in that case? Maybe, maybe not, and you'll be smart if you just made a choice either way. So what is a common scenario for something like this? And we've seen this in real life. So this is just a scenario without names of people that actually ran into this scenario. So it's this major cloud that someone's put up, and it's a private cloud. And let's say the organization has multiple departments, and some of these departments have engineers, perhaps, and some others are marketing folks and finance folks and so on. And these different sub-organizations don't really want to share the same kind of resources with each other. I mean, that's the kind of policies that enterprises have evolved into enforcing in their environments. So, but they have this large OpenStack cloud that's actually serving all of their infrastructure needs for them. So, and it's multi-tenant, it's got different kinds of storage, maybe, or it's just got one class of storage. But what happened with this particular scenario was that they had two different classes of storage, and they wanted one department to just have access to this class of storage. Actually, they had more than 2 classes of storage. But one department wanted to be constrained to this particular class of storage, and the other departments could actually go move their workloads between this and this, depending on some sort of a policy, some sort of time frames, and so on and so forth. So this was perfect for how they were running their OpenStack clouds, because all of this is easy when using Cinder or Manila and OpenStack. And how do we do that? We use Manila's share types or Cinder's volume types. What about day 2 operations? We use all the data motion APIs that both these services already expose. And that's when, this organization told us, well, we're running container orchestration engines, and we'd like to give each of these orgs their own CO. So their Kubernetes workloads of the marketing department are not the same as, they don't have to share the same cluster or exhaust this cluster that's actually used for dev and test and stuff like that. So these were, that's just one use case, but several of these use cases were being pooled, and that's kind of where we got this whole idea of us as the Manila community, us as Red Hat, us as, large users of shared file systems, to go explore this option of making Manila available to COs directly, using this architecture to enable some sort of a easy management, a single pane of glass kind of deployment when you're using OpenStack to do your infrastructure management. So a while ago, the Manila Dynamic Storage Provisioner was written, and it's been working well. People have been using it in production. A big use case is CERN. They've been using it for about over a year right now, and it's been working absolutely fine for them. But if you've been to some other talks at this conference, or if you've seen the history of how storage orchestration has evolved in container orchestrators, you'll realize that dynamic provisioners is no longer the way of doing things. Even if you're running just Kubernetes. So everybody's moving on to doing CSI, because there's major architectural changes, as well as all the new feature sets are going to just end up being written into the CSI spec, and using CSI as the way to talk to your storage. So that's where we started thinking about CSI, and CERN was making similar things with their Manila. Internally, they started exploring writing a CSI driver, and they have a really cool talk that you should probably listen to from the last OpenStack Summit in Berlin. And they actually, this wasn't the most elegant solution, but it was cool. They used the Manila Dynamic Provisioner to just take care of the provisioning, and they were using the Ceph CSI driver to do all of the node level management of the storage system, of the storage that was being provisioned. And with Kubernetes 1.12, Kubernetes added a new skip attach feature for distinguishing, things that actually don't really need to go through multiple stages of attaching your storage, which is typical of block storage. And this helped them get a huge performance gain as well when using Manila in this fashion. And so at the same time, we at Red Hat were talking and thinking about it, as well as with the Manila community, all of the different storage vendors that already have their drivers written into the Manila code base. And we thought, okay, this is time to go start working on a CSI project. And there were 2 separate PRs that just landed close around the same time. And that's where we are today. And with the kind of collaboration that we started having with folks from CERN, the OpenStack folks, the SIG storage folks, SIG OpenStack folks in the Kubernetes community, and the Manila community itself, we evolved a different in an architecture that we think is sustainable going forwards for how to use Manila in the container orchestration world. So here's the first piece of it. This is the provisioning piece. This is where the Manila CSI provisioner is going to be, the the controller service implements the CSI provisioning spec. It's going to take care of creating your shared file systems, access control for these shared file systems, all of the metadata handling that goes into the provisioning part, or even the deprovisioning part. That's the responsibility of the controller service. But unlike many other kinds of storage, we really don't have those many needs when we get onto the, oops, I may be missing a slide here. Okay, we don't really have those many needs as we get onto the node side of things. And what I wanted to show you over there is Manila is just going to finish provisioning the system and then rely on other parts on the node side to do the node side attach and detach. And that's how this design is currently written. Okay.
Okay. So what are we doing with this? So there's Manila CSI pull requests from Robert Bashek at CERN is pretty much ready to merge upstream. It's not a small piece of code. It's got a lot of endorsements and so on, but we're in the business, we work for Red Hat, and we're in the business of making products and not just upstream science projects. So we want to test this end to end. We may find some bugs, things to shake out, and so on. So we've set up a little lab. Actually, it runs on as you see, it's a Kubernetes cluster where the Kubernetes nodes are actually running on OpenStack Nova instances, just kind of incidental. They're part of some of you guys know RDO Cloud. So we run it on an OpenStack cloud. We have Ansible playbooks to deploy it. And it also deploys a OpenStack dev stack at this point. And the dev stack is that minimal set of services that I just talked about, partly just to prove the decoupling, and partly because why run anything we don't need to for this? And it's got a Golang environment and container runtime control and so on. So it's a nice environment for developers to test ideas, experiment, try out things. It deploys Robert Bashek's, he's also the author of the SelfFS side of the SelfCSI driver. So it deploys the SelfCSI driver, it deploys cloud provider OpenStack, which is the framework in which Manila CSI fits. So that's all automated deployment, so we can push a button and get it up and running. It'll deploy his latest version of the PR, so we can keep up to date. So it's like almost like an upstream CI environment for DevStack, but it includes the Kubernetes stuff, and it's kind of inverted in that we're actually running the little OpenStack part inside Kubernetes. More on that in a moment. We're running it just on the bare metal node at the moment. But what are we doing with it now? We're working on doing end-to-end tests with the Manila CSI stuff. So it can merge and we can be confident of it before we look at downstreaming and productizing this stuff ourselves. And we're trying to move full steam ahead on doing that. We're also, some of you may have gone to some Rook presentations. This is a great environment for us to deploy Rook. Right now we're deploying, we're particularly interested in the Ceph backends, and we're deploying Ceph at the initial stage just as part of DevStack with the DevStack plugin that we do when we test Manila upstream with the Ceph backend. Uses, doesn't even use Ceph Ansible, so it's just it does it the old-fashioned deploy Ceph the hard way method. So the next thing we're going to do once we get this stuff working is start deploying Rook in this cluster and then hooking up Manila to an external Ceph cluster from the point of view of Manila and DevStack. It's still running on these RDO Cloud stuff and it's still small scale, but it will exercise the interface will be just as if it were a huge, big scale out SelfFS cluster. And we'll use Rook to do that so we can exercise that. Jeff Layton has done this at small scale. He's a developer at Red Net and a NFS kernel guy from way back and so on, works on Ganesha these days. So he's been working on with the Rook developers on deploying Ganesha or Ceph, or as it's called in that context, Ceph NFS with Rook. So we want to do that, and that way we'll be able to test working with an external Ceph cluster, both for Ceph and for Ceph with NFS. We want to, one of the challenges, both for Manila share service, which is like sender volume service, the service back on the diagram I did, I won't pull it back right now, that actually interacts with the storage, is that it runs today in an active-passive manner, and we have to manage it by pacemaker. Similarly, Ganesha today, as we ship it, runs where you can only run one active instance at a time. Well, this idea is also represented in the Kubernetes world as a stateful set, basically. You can use a similar idea. So this will be a playground where we can play with the idea of using stateful set control rather than pacemaker control to basically reincarnate a service, a single instance of a service, if we need to. We're also working at the same time on the Manila front to run it active-active so we can run more than one of them at a time and scale out it that way. But this will be a good playground for us to work on those issues. Next, we want to put Courier in the mix. Okay, now why do we want to do that? If we go, this is kind of the picture where we moved the Ceph daemons out under Rook control and under a Kubernetes cluster. We've been showing this to people for over a year now, is where we want to go. And where we don't have a single Ganesha service anymore, but we can scale them out, and we can ideally do it per tenant. We do this kind of thing with proprietary backends. I see some people in the room from NetApp. It works very well with NetApp today. This kind of, in Manila terminology, it's a DHSS equal true framework where you have a different virtual file server for each tenant if they need it. Well, we can do that with Ganesha. We'll have to make some changes on the Manila side. We'll have to have this stuff in place for doing Ganesha on the scale-out side on the servers. And the challenge then is to integrate the Kubernetes networking back into OpenStack, and that's where Courier comes in. And we talked to the Courier people probably 3 cycles ago about this. And they assured us they know how to do it. We were talking to them about it, and we actually want to try it out now in this playground. So in summary, where we are working on this stuff is we're going full steam ahead with an intention to effectively start providing something that's product on the Manila CSI. And we're exploring these other areas, and we're using, they all involve synergies and overlap between Kubernetes, which is our container orchestrator of choice, and OpenStack and OpenStack Manila. And that's pretty much it. This is just a summary of the things I've said. I know I'm supposed to do a sandwich and repeat them, but you can read them. We had another name at the beginning of our slide, Victoria Martinez de la Cruz. Would you just wave your hand to everybody? She just came in, wasn't able to talk with us right now, but she's been especially instrumental in driving collaboration with CERN and with the OpenShift people or the Kubernetes people at Red Hat. So thanks, Victoria. Questions? Anybody have questions, comments? Fruit to throw? Gautam's here for that. Would you use a mic, please? Thank you.
So at a minimum, we need Manila and Keystone, right? And with Keystone tokens and Kubernetes, how do you all?
So one of the things I didn't really indicate in terms of the slabs, we're interested both in large scale out infrastructure where you have an OpenStack cloud, you may be deploying it already for other reasons, and you want to support one or more container orchestrators and other workloads. In that scenario, each container orchestrator deployment, I don't mean Apache versus Mesos versus Kubernetes or something, but Kubernetes 1 and Kubernetes 2, et cetera, is a Keystone tenant. It's just an OpenStack user. Now, the container orchestrator will have its own notion today of multi-tenancy. Today, in pure upstream Kubernetes, that's some relatively limited RBAC and stuff. If you look at a product like OpenShift, it's much more sophisticated in terms of controls and their notion of multi-tenancy. There are people thinking about how to look at having common notions of multi-tenancy in both worlds. I know that's kind of that's not a storage R&D area, but we would certainly leverage that if it works. That's one scenario. Then there's the other extreme, and it's I kind of pointed to that a little bit, where we took a few services that run in Manila today, just the Manila services and the RabbitMQ and MariaDB. Now we could run that with a single container orchestrator, and Keystone in that picture then goes away. It's optional. There's just a single tenant from an OpenStack point of view in that scenario. So am I answering the question?
Yeah.
Okay, so there are a lot of possibilities here. And part of what we're hitting here is that there are a lot of permutations, right. And we're going to see some shakeout. We're going to see some things that we think are cool ideas not have any interest, from real product people.
All right, thank you.
Yeah. How was that for a short answer? Any other questions? Comments? Well, I want to thank everybody. Our contact information is on that first slide. So if you have further thoughts, we're going to, slides will be posted and so on. If you have further thoughts, feel free to follow up, correspond by email, whatever. We'll be glad to follow up with you. I'll be at KubeCon if any of you are there, and the SEP days there, talking about similar stuff. Not the same talk, though. Okay, thanks.
Thank you.